Nexus Agents is a deep research system I had previously started building. I had implemented an analytical report research type where you can research a topic and it will decompose the topic into subtopics and then spawn different search agents to gather information on the subtopics, summarize each of the sources, analyze the synthesis, and then create a couple of artifacts. One is a research report, and another is a taxonomy of knowledge, insights, and spiky points of view. What I did during this hackathon was extend it to a brand new type of research task, which is a data aggregation research task, so that I can gather all information relevant to a certain search space, identifying an entity like private schools, attributes that I'm interested in for each entity, and a search space to enumerate and then fire off search agents in each of the subspaces, with some domain-specific processing to have a pluggable system to have specific business logic for certain kinds of domains. Upon firing this off, you can see it begins to enumerate the search space for private schools in Arizona, and it created this list of different counties, and so we'll now proceed to search individually in each of these counties, Apache, etc. There are 10 parallel workers, and so it goes through, in this case, 15 subspaces, 10 at a time, performing massive searches across various providers, including Linkup, Exa, Perplexity, and Firecrawl. I will pause now while this finishes searching, which will take a while until it goes to the next phase. So what I had done before, and something that I think is really useful for Cline and certain kinds of highly automated software development agents, is to create a specification for what needed to be done. This is usually done in conversation with a capable reasoning model. I basically laid out the desired functionality of what I wanted to implement for the data aggregation, and that was then handed off to Cline to review and implement. Was able to then operate autonomously for about 4 hours in order to implement most of the functionality. It then needed several rounds of troubleshooting, but it's amazing just how far it got based on the spec. So here I'm going to fire off a new research task where the entities are private schools. I want these attributes. The search space is Arizona, and this is the domain-specific processing I want to fire off. In this case, because the search space is a state, it's going to decompose the state into component counties. Arizona has 15 counties, so it should identify all 15 of them. Here it identified the different counties. If we switch over to the user interface, then we can take a look at that research task and see the search space enumeration, and we can see all of the counties that it identified. So it's going to fire off individual searches in each of those counties in order to retrieve more results than just searching across Arizona. There are 10 parallel workers running here, so it's going to search those 15 counties 10 at a time, and then the results are going to start coming in. After it finishes searching, then it will extract from the database all of the search results in order to identify the different attributes. You can see it is finished processing and extracting all of the data, and it got a 293 completed, and now we can take a look at the user interface and see the extracted entities, and here they are. In some cases we have some address data available. The rest of the data is pretty sparse for this data set. We can also download the data as a CSV, which we can then open up in a spreadsheet. So this can be used for other data processing workflows. It is also stored in the Postgres database. So we essentially have a large-scale data aggregator in place. If I add more domain-specific processing for schools, we can add some suggestions on where to pull additional data from. And if we increase the max results per subspace, we can also get more data. But right now we have a minimally functional system.